Let me record on this computer. Okay. And we will be creating our next class, which we will call Demo Keyboard Handler. Demo Keyboard Handler. And this will be a child of JavaFX application object with a public static void main. As before, I will be grabbing some of the stuff from the previous projects. So let me do that here as well. Helps me save some time. Okay. Working with keyboard. Okay. So instead of a vertical V box, a vertical box, I'll just use the pane. So we're creating an instance of text object that we did before as well. And to the pane, we would like to get the children to add the text. Okay, so we have added the text. Let me run it just to make sure. So I have my text done. I have my text in my pane. I have my pane and my scene. Oh, I forgot to do the launch. No wonder nothing was showing up. Launch. Okay, cool. Here we go. Okay, so here we see the pane. In the pane, we see the text, and the text currently shows the letter A. Now to the text object, I will add set on key pressed. That's the event. I'll be using, again, the lambda expression. That will take care a lot for me. I do not have to write that override kind of stuff. It does everything for me. All I need to worry about is the actual code. So I'll be using a switch case. If my object for action, I'm gonna get the code, means whatever key gets pressed on the keyboard, its ASCII code is with me. Okay. Now, if it's the down key, then I want oops. Why am I adding 10 on the down key? Why am I increasing my Y value on the XY coordinates on the down arrow key?
To scroll?
Because remember, this top left corner is 0, 0. So down arrow key means I want to go further away, you know? So to go further away on the y-axis, I got to add value. Down arrow key will take me away from the origin. The origin is 0, 0, which is in the top left corner. So this is 0, 0. So when I hit the down key, then it should actually take me down, okay? So that's what basically I want to do. And then in case of up arrow key, I want to decrease it by 10. Then in case of left arrow key, I want X to be decreased by 10. And in case of, right, I want X to be increased by 10. So I'm going away from the right. Okay. So I have the pane, I have the text. I add the text to the pane and on key pressed. Now, one thing I got to do to make this happen is that when the actual application launches, the focus is not on the text. So I got to say, you know what, when the application launches, I want the focus to be on the text. So now when I run it, okay, my arrow key is actually controlling the A. Okay. Now with this kind of an approach, can I not design different kind of games like Snake and stuff like that? Of course, definitely. Just the displacement of an object. Or games like hitting objects and stuff like that. It's just being controlled with the arrow keys.
Recreate Minesweeper.
Yep. Absolutely. So if you could give me a green check if you're done. Greg and Francisco are still working on it. Got it from Greg. Waiting for Francisco. Okay, cool. Now let's save this example as demo mouse handler. Demo mouse handler. So instead of on key press, I have another function which is called set on mouse dragged. Set on mouse dragged. Okay. Now, set on mouse dragged I got to do this, that I want wherever my mouse gets dragged to, I want that should be the X and the Y location of my text. So whatever is the mouse location, that's being held inside by the E. So the E is now working for the mouse. So I'm just grabbing the X and the Y location of E, and I'm assigning that to the text. That's all I'm doing over here.
Can you remove the switch.e get code? Yeah. Okay.
Yep, I did. Yep. So see, I can now drag and move the text around on the canvas. Okay, everybody got this? Okay. Now let's save this as demo radio button, because we haven't done a radio button handler like we did for the checkbox. So let's do one for the radio buttons as well. So I'm changing the text to say Java programming. I'm leaving the name as pane. However, I changed the class to VBox. I'll have my radio buttons. And then I'm adding all 4 of them to the VBox. But since I'm using VBox, I got to use the function add all, which is different from adding it to the pane. Add all. Okay. And let's get rid of the event handling part. Let's see how it looks like right now. Okay. Right now, as you can see, all 3 radio buttons can be selected. How do we fix that?
Group, toggle group.
Toggle group, very good. So we create an object of toggle group. And what do we do after that?
Option 1 dot set toggle group.
Yeah. So for each radio button, I got to set it to a toggle group.
Oh yeah, I said option 1 because that's what we did it in the registration thing. That's where I was going back and looking.
Now text dot set font. So here we have, right now you can only select one of the 3. So here we need to add our event handling. So what I want to do is when I hit the red radio button, the text color of the text should turn red. Okay, if it is selected. If it is not selected, then shouldn't. So red R dot set on action E lambda expression, because lambda expressions make our life so much easier. Okay, if red R dot is selected, then text dot set fill to color dot red. And we got to repeat that for each one of them. Okay, everybody got this?
I just need one moment. I'm almost done.
Sure.
Okay, I'm good.
Okay. Let's see, what about Greg and Robert and Francisco? Oh, okay. Robert and Francisco and Cole. That's better. Okay. Okay. Now, come on. Now my clips has gone crazy.
Oh, class is over.
Let's try again. Eclipse, where is that? There it is. That's okay. Cool. All colorful, right?
Now the colors match, so I know if I'm doing it all right.
What others do we have? Like we have system. How's that? Okay. And then we have classic.
They're all horrible besides dark.
Oh, that's all. That's the same. Okay. And light. Light not really doing what it's supposed to do, right? In dark.
So much easier on the eyes.
Yeah, but for some reason, it just, okay. It says a restart is required for the theme change to take full effect. I think that's what it did. Okay, anyway.
I must use a different one.
Now let me close all these and let's go to our next topic for today. And that is working with main thread as thread programming. So main thread example. This is not a Java FX stuff. So let me first of all explain to you what exactly is a thread. Thread is a lightweight process. So what that does is when you're running an application, your application always runs inside a thread called main, which is generated by the method main. However, it is possible for you to create other threads in parallel to main. And since we are in a world where we have multiple processors, we could be running threads simultaneously coming from the same application in parallel onto different processors. And that's exactly our focus will be this week and also the next time we meet when we talk about multi-threaded application is to be able to create multiple threads and be able to work with them. Now, the biggest challenge comes in, which we'll also talk about not today, but in 2 weeks. that when multiple threads are sharing a resource, okay, that's where the problem comes in. When they're accessing the same resource, it's very important for you to sync them. If you don't sync them, what happens? Some of them get the latest version, some of them get the old version. They work with the old version, and by the time the other guys who have the latest version, they come back with the latest version, the old guys come back with their version, and everything gets all mixed up. So that's something that we will be looking at in terms of multi-threaded application. And that will lead us to Java network programming in a couple weeks or 3 weeks, whenever. And then we will be looking into that how you can create a client application and a server application and make them talk to each other using networking protocols. Now, where does the multi-threading comes into place? When you have multiple clients talking to the same server. Each client is a thread. So that's how the server can differentiate between different clients. So you're pretty much looking at building a chat application, for example. Okay, so that kind of stuff is what we will be dealing with in the next 3 weeks or so. And then we'll bring in generics into the picture. We'll bring in Java XML programming into the picture as to how Java talks to an XML document, retrieves data from an XML document like a database, or produces an XML document on the fly, traverses through an XML document. So all of these topics will be with us for the next few weeks before we tap into the Java database connectivity. Okay. So for now, let's look at the threads. In order for you to create a thread, all you need is to create an object of thread type. Okay. That creates the thread. Now, you can ask your thread, okay, I want to know your name. So you can actually grab its name. So you can actually say, okay, name of thread object is, and then you can display its name. And that is thread 0. Okay, that's the default name given to it by the system. Then you can say, you know what, thread? I want to set your name to something else. I want to set your name to Mario Brothers, right? Mario. So, and the new name of thread is, oh, 1 second. I need to grab the name again. And the new name is Mario. So you can create a thread, you can give it a name, and then you can interact with it. Like that, you can create several threads. However, this is a user-defined thread right now. Now, let's ask name to go to the thread class and ask for the current thread's name. Okay, so name of current thread object is, and that's main. So right now, in this example, we have 2 threads running concurrently. One is the current thread, which is the main, which is in which my application is running. And the other thread is called thread, which I created as an object on line number 5. Okay. I don't know. Do you guys do any thread programming with Alan, or do you guys do it, or will do it? I don't know. in the .NET programming course I'm talking about?
We were doing that just on Monday.
Okay, okay. So I mean, like concurrently, you're looking at multi-threaded applications on both platforms. The idea is very similar, though. The code implementations will be different. Okay. Now, let's create a new class. New class. We're going to call this one thread sleep demo. When you make a thread sleep, there is a likelihood that somebody may intercept and will try to wake up the thread. In that case, the thread could yield an error. To fix that problem, we always make the thread sleep in a try-catch block, with catch having an interrupted exception. Okay, so now I have the word Java, then ask thread to sleep for 1 second before printing the word programming, and then sleep again before printing the word is fun. Okay, that's what this application is supposed to do. So Java programming is fun. Okay, so let me run it again with one more spacing so that it looks like a step. It's like animation. So that's what basically the gist of animation is. When you're animating text, it's all thread based. You're making the thread sleep. That's how you animate. Okay, everybody got this? Okay. Now let's create a new class, which we will call custom thread, but this time, this class will be a child of a thread class. So we, instead of creating an instance coming directly from a thread class, we want to customize our threads. So in order for you to customize your threads, you can create your class as a child of a thread class. So superclass is thread with a public static void main. So now I can create a constructor. And in the constructor, I can say, okay, pass me some kind of a string, and I will then call my parent class and use that string to set the name. And then I will call the start method in the parent to then call the run method to run the class. You cannot directly call the run method. You have to call the start method, which then calls the run method for you. So when you have a local version of run, of course, this is now overriding the one in the parent. So now when the parent start method makes a call to the run method, and since the call came from custom thread class, it will call the run method in the local class. Okay, again, I'll use my try-catch block for interrupted, exception, So what does the run method do here? Whenever the thread starts, the thread automatically gets started as soon as the constructor gets hit. As soon as the constructor gets hit, the thread starts, the thread gets a name, and the thread starts on line 6. It calls the run method. What does the run method do? Run method runs a piece of code how many times? How many times the loop runs?
10.
10 times? Okay. Every time the loop runs, what does it do? What does the
It-
loop do? Yeah, go ahead.
It adds to I.
Yeah. I mean, like, it, of course, I is incrementing, but what happens inside the body of the loop?
It'll print out the thread name and then wait for 1 second.
Exactly. So it prints the name of the thread, which is thread.currentThread.getName. So it grabs the name of the thread, displays it on the screen, and then waits for a second. Does everybody follow that? Okay. So how many times, how many seconds will it take for the run part to run?
9.
10. Because I mean, like a little bit, I shouldn't say 10, a little over 9, less than 10, because there's a latency between displaying and sleeping and displaying and sleeping. Right. Exactly. So now if I makes it equal to 10, now it'll be 10 times, right? Okay. Now, add that equals. Now let's say if I create a thread object here called custom thread, thread 1 equals to new custom thread, and I pass my thread. Okay. So the name of the thread is thread 1, and it is an object of custom thread type. So when it says call the constructor of custom thread, my thread goes to name. Okay. The name of the thread becomes my thread, exclamation mark. It starts the thread, which calls the run. The run method will print my thread 10 times with a delay of 1 second. Does everybody follow that part? Okay, so now let's run it. Okay, so when you run it, see, after a delay of a second, it displays that 10 times, and then it stops, terminates. Okay, now let's try one thing. Let's copy line number 21 and paste it again and call this one thread 2 object. And we're going to call this one my thread 1 and my thread 2. So how many threads do I have? 2 of them. Okay, now let's run it. No, you will notice when you're running it, they don't really run in a sequence. Okay, it is not like 1 2 1 2 1 2 1 2 1 2 all the time. It could be 1 2 2 1 1 2 1 2 1 2 1 2 and 1 1. I mean, like they will just go by whatever is available because they're sleeping. Notice here 1 2 2 1 1 2 1 2 1 2 1 2 1 2, and then it goes in a sequence all the way through. Okay, now let me add maybe like 4 threads running concurrently in the memory. I got a thread 1, thread 3, and a thread 4. The thread 3, thread 4. Okay. So I'm running 4 of them. Okay. Now notice their sequence. Is there any particular sequence? Does the thread 1 starts before number 2? No, there is no guarantee. Every time you run it, they just run differently because they're being picked up by different processors. Whoever is free, they take up a thread and throw it out there. Does that make sense to you guys? What's going on here? Okay. Now I want you to copy these 4 lines the custom thread, thread 1, thread 2, thread 3, thread 4, right? Copy these 4 lines. And now let's create a new class with only a public static void main. And the name of the class will be custom thread implementation 1. Custom thread implementation 1, and hit finish. Okay, now instead of thread 1, thread 2, thread 3, thread 4, see how what I'm calling them? Car 1, 2, 3, 4, right? Okay. Now instead of my thread 1, I'm gonna call this one okay. Okay, let's see who wins the race. And who comes last? Ah, Lightning McQueen lost the race. Right?
Is there a reason why your output would be the same as mine if it's random?
Let's try again. Is it same again?
Mine's just about finished.
See, this time Cruz came last.
Just weird luck then.
Yeah, probably. So once I create that custom thread, I can just customize it to whatever application I want it to be. So if I'm creating something like the racing game as a thread base, I could create multiple threads and I can make them all run. And whichever one comes in the end is the one that loses. And I could play, I mean, like several times to see different results. And then I can, if I'm taking this all the way to my Java FX application, what can you do? You can actually make them labels with the actual images of the car. And then you can then display them once the process is done. Right? Okay, now let's save this as, oops. Let's save this as custom implementation 2. Okay. And let's, oops, I forgot. Okay. Come on. Custom implementation 2. Hover over, change the name. Okay. Now I'll be taking it down to 2 objects, custom thread. And now that's a funny name, right? Now wait till I give them names. Ha, right? Okay. running pretty smoothly. Come on. Come on. No, I don't like that outcome. Let's
Womp womp.
wah, wah. Maybe I should make it run a bit longer, right? Let me make it run like maybe like 50. I don't know.
Is yours going every other?
It just depends, you know. I mean, like, it. That's why I made it 50. You have a little bit of a variance there, but you know, looks like I'm a hard luck. So anyway, you know, I mean, like, you can have all sorts of crazy fun with the threads. Okay, now let's go back to the custom thread.java. This probably may not be a good thing to do if your class is already a child of another class. You know, if your child is already if your class is already a child of another class, and you also want your child to be a thread, this solution will not work because you can only have one parent class, right? Okay. Now let's save this example as custom thread number 2, custom thread 2. Okay, so let me hover over and change this to custom thread 2. Okay. In that case, instead of making your class a child of thread, you can implement an interface called runnable. That's especially designed for you to be able to create threads in case if your class is already a child of another class. Okay. In that case, right, you cannot call super. You cannot call start like that because runnable doesn't have any of that stuff. What you can rather do is this. You can take an approach of creating a thread object every time the constructor is called. You can just initialize the thread object to whatever name you want that's being passed to the constructor. And then you can tell the user some kind of a message that's starting thread. And then you're going to give it and you can display the name of the thread that you're starting. And then you can use a thread to call the start method. Okay. And that start method will then call the run method down below.
Are you trying to figure out why it's not repeating?
Yeah,
Because at the bottom in your main, you have public or custom thread 2. You should just take the 2 away from the in front of thread and after thread, and then it works for me.
oh no, but then that will call the other class, which we created before. We want to call the constructor of this class, not the other class. So it calls the constructor of this class, custom thread 2, and that starts, and we can see that it's getting started. But it is not calling its own run method. Let's see if that works. Oh yeah, I actually had to call the run method. I think that's what I'm missing. Let's see. Okay, thread dot. Displaying the current thread name. Constantly showing main. Thread dot. Thread 1 dot run. So the first one ran, it ended, and then the second memory came into place. Just 1 second. So I actually moved it to a different class to see if that would make any difference. But apparently not. Okay. Just keeps tapping into the main method. Hmm. Because that's what the current thread is. Okay. But here, because we were calling through the constructor, and the constructor was calling the start, and the start was calling the local run. That's why that seemed to work fine when it was a child of thread. As soon as we move it to runnable, that's when it starts making all these crazy things. Simply tapping into the main. Thread dot get current thread dot get name. Okay. Run the bullet quotation. Oh, interesting. Okay, let me try taking this approach. Thread T1 equals to new thread. The first argument will be thread 1, which is my runnable interface, followed by its name, let's say Sam. And then let's do T2 and make this one Andy. Okay. Oh, my bad. And then do T1 dot start and then T2 dot start. Here we go. Okay, so after we create a runnable interface, so this is just an interface. So we got to then give that interface to a thread object and then name those thread interfaces. That's what I was doing wrong here. Okay. So create an interface object to be able to run, and then give that interface to the thread objects to start. The rest of the program stays the same. You can drop the constructor. Sorry, you can drop the constructor. And that's the rest of the program.
So you removed public custom thread 2 altogether?
Public custom thread 2.
Originally, you had a code above override.
Oh, no, yeah, I deleted the constructor.
Okay.
Yeah. Okay. Now, please have a look at this week's homework assignment. Any questions about the assignment? Okay, guys, then that's all for tonight. And I'll see you guys in 2 weeks.
Sounds good.
Is this due next week when we don't have class, or is this due in 2 weeks? You know?
That's a good question.
That is a great question, right? So how about if we extend all of this stuff till the 5th?
Sounds great to me.
Josh, You're
Yeah,
welcome,
you-
class.
Thanks, Josh. Thanks, Josh.
Thank you, Josh.
Thank you,
Okay.
Saad.
No problem. No problem. Okay,
See you in 2 weeks.
you take care. Yep,
See you in 2 weeks.
in 2 weeks. Good night.
Have a good night. Tried having the camera on the whole time.
Thank you.
I'm gonna
for
try to do
doing
that from now on. See if I can.
Thanks for doing that. Yep.
Makes it easier to pay attention, actually. It seems like, at least. But yeah, have a good couple weeks.
You do. Thank you. Acting up now. Oops.